first, let's integrate tanx dx. Okay, I'll solve this in two ways. Okay. I'll solve this in two ways. Okay. One is very short and simple. The other one, okay. Okay. You know that in trigonometry, tanx is something as tan of any angle is something as sine of that angle divided by the cosine of that angle. Okay. So if you call this equation 1 and call this 2, if you use 2 in 1, we'll have this will be integral sine x over cosine x dx. Okay. Now in integral calculus, if if you get the numerator by integrating the denominator, okay, it's the same thing as when you take the logarithm of the denominator. Of course, you add a constant of integration. Now, if you differentiate the cosine x dx is negative sine x, so it doesn't give us an but negative. So what we try making it so we can multiply a negative, of course, and put negative in there, all over cosine x dx. Why? Because we've not changed it. Negative is positive. We'll get back the equation, the function. Okay. But now, if you differentiate what cosine x, we have negative sine x, and so this will be negative log of cosine x plus constant of integration. Now, in logarithm, if you have a log maybe x is something as log x to the power of a, even if its natural logarithm is the same. Okay, that is, if it is a, natural logarithm of x is something as natural logarithm of x to the power of a. So if we do that here, we would have cosine x negative 1 plus c. So is natural logarithm of 1 over cosine x plus c. 1 over cosine x is sec. It's something as log sec x plus c. So it's the same. Okay? Or alternatively, you can do it this way. You can say that is integral tan x dx. You can say let t equals, call this one, equals tan x. Okay? So if you differentiate, this is 2. If you differentiate 2 from equation 2, dt, differentiate tan x, you get sec x squared, sec squared x dx. Okay? So dx will be equal to dt over sec squared x. Okay? So this is equation 3. Now, if you use 2 and 3 in 1, you will have integral tan x is t, dx is dt over sec squared x. Okay? Now, 1 plus tan squared x is something like sec squared x. Okay? And is a trig identity. 1 plus tan squared x is sec squared x. So we can replace 1 plus tan squared x with, sec squared x with 1 plus tan squared x. So that will give us t dt all over 1 plus, because tan is t. Okay? 1 plus t squared. See that? So we are now having integral t dt all over 1 plus t squared. Okay? Now, I can make another substitution. I call this equation 4. I can say let v equals 1 plus t squared. Okay? What does that mean? I will now have equation 4 becomes integral t all over v dt. Okay? Call this 5. Now from this equation, dv is something as 2t dt. So that we remove, this is in terms of v now, we remove dt. So dt will be equal to dv all over 2t. Call it 6. If we use equation 6 and 5, we'll have integral t over v dv all over 2t. So you see, t cancels t. We have integral half dv over v. That will be half of natural logarithm of v. Now, in logarithm, we can, if we import the log of logarithm, is something as having natural logarithm of v to the power of half. Okay, but what is v? V is 1 plus t squared. See, you have natural logarithm of 1 plus t squared to the power of 1 over 2. What is t? T is tan x. Of course, you add the concept of integration. T is tan x, so we have half in of 1 plus t is tan x, tan squared x, tan squared x, because t is tan x, to the power of 1 over 2 plus c. Now again, look at this equation. 1 plus tan squared x is sec squared x. So we have natural logarithm of sec squared x to the power of 2 half plus c. So add the square root of that. It gives us natural logarithm of sec x plus c. So this and this are the same. So this gives us the same, gives us this, and any one you like you can use. They will both give you the same thing. Thank you very much.